That's why it is called the primary motor tract. Comes from the primary motor cortex. Other motor tracts are vestibulospinal, tectospinal, rubrospinal. You see, all end with spinal. Rubrospinal, vestibulospinal. There is another one called tectospinal. I didn't show here. Anyway, so if you see, they end with spinal, that's motor, and the most important one is this one. So remember this one, what I said. Okay, now the relay of sensory signals. When I touch my skin, that signal is taken to the brain, right? All the way to the brain. And in different locations, the signal is relayed because one neuron is not that long, I mentioned, right? Not that long that it will take all the way to the brain. So that's why you have the relay stations. So you already know part of it. You see, this is the spinal cord I did draw a few minutes ago. This is the gray matter, dorsal horn. These are sensory neurons. There is a ganglion here. These are sensory neurons. Remember that? Yes or no?
Yes.
Okay. And these are motor neurons in ventral horn, motor tract, the root. This is the spinal nerve. The spinal nerve is a mixed type nerve. Okay. So, anyway, the sensory signal, this is the body. So, if I touch the skin here, okay, that signal will go this way and this way because this is sensory. This way. And these are the neurons, first group of neurons or first set of neurons that will receive that sensory signal. So, the neurons in dorsal root ganglion, dorsal root ganglion. These neurons are the first order neurons in sensory pathway. Then these neurons will send signal to these neurons, right? This way. So these are second order neurons. Makes sense, right? So second order or group of or set of neurons. So first order, these are second order neurons. Make sense? Okay. And then from the spinal cord, the signal will go to mostly to the other side, opposite side, to the thalamus. These are thalamic neurons. Anybody remember thalamus is called what?
Major relay station.
Major relay station, right? What kind of relay station? Sensory. Major sensory relay station that I mentioned in last class, right? Almost all sensory signals are relayed in the thalamus, finally. So these are the third order neurons. In the thalamus. So first order neurons, second order neurons here in the dorsal horn, and third order neurons are in the thalamus. Three sets, right? In sensory pathway. So one group of neurons take the signal and give it to another group of neurons, then signal from that group of neurons are given to another set of neurons. So if I ask you that first order neurons are located where? Inside the dorsal root ganglion. Make sense? And second order neurons are located inside the dorsal horn. Make sense? And third order neurons are located inside the thalamus. Is it clear? And then from the thalamus, we'll go to the primary somatosensory cortex. You remember here, postcentral gyrus, primary motor, primary somatosensory. So these are the sensory neurons. Finally, signal will go to the cortex, primary sensory cortex, somatosensory. Okay. So that is the sensory pathway from the body first to the dorsal root ganglion, then to the dorsal horn neurons, then to the thalamus, then finally to the primary somatosensory cortex in the precentral. Makes sense, right? Complicated, but makes sense. You have to understand what's going on. Okay. Let's see next. Here, you see from the skin, dorsal root ganglion, dorsal horn, and goes all the way to thalamus. Okay, all the way to thalamus. This is the thalamus, then to the somatosensory cortex. Okay, so that is the sensory. Now, if we see motor, motor goes in opposite direction, right? From the brain to the muscle. Not from the skin to the brain, from the brain to the muscle. So, this is the primary motor cortex. This is rather simple. Primary motor cortex in the brain, primary motor. What happens? The signal from the primary motor neurons go to the ventral horn motor neurons. You must remember, these are the motor neurons in ventral horn. So you go to the ventral horn motor neurons. So one set of neurons are here in the primary motor cortex. These are called upper motor neurons in the brain, upper. And another set of neurons in the ventral horn, you already know. So these are lower motor neurons. So only two sets. Upper motor neurons in the primary motor cortex, right? We already know primary motor cortex must have motor neurons, right? Because its name is primary motor cortex. And you already know that ventral horn has motor neurons. So those are lower motor neurons in the spinal cord. And from here, the signal will go to the muscle. Will go to the muscle. There is no ganglion in ventral root. So no more neurons going directly to the muscle. Okay. So you have learned the sensory pathway, right? And motor pathway. Something interesting here is, see, upper motor neurons from the brain sending signal to the lower motor neurons in the spinal cord, right? And lower motor neurons send signal to the muscles because motor. Now, it is important to know that lower motor neurons do what? Contract. Contract the muscles forcefully. Lower motor neurons are hyperactive. Okay? Hyperactive. Try to contract the muscles what? Strongly. Is it clear? And upper motor neurons are sending signal to the lower motor neurons all the time and telling the lower motor neurons, don't be hyper, okay? Slow down, come down, okay? Make sense? So let's go back again. Lower motor neurons are telling the muscles to do what? Contract forcefully. But upper motor neurons are telling the lower motor neurons to do what? Don't be hyper, okay? Don't contract too much. Make sense? So that's why the muscles are partially contracted. That's muscle tone is there, right? Always we have muscle tone, right? But not fully relaxed, not fully contracted. Make sense? Okay. Now it's like, you know, when you take your small kid, small child to a park, right? You let him play. Okay, play, but stay within this area, right? Don't go far, don't go beyond my sight, right? You sit down or read a book or do something, you don't want to play. Right? So you read, and, but keep eye, right? Keep eye on your child. He doesn't go too far, right? So, lower motor neurons are hyper. Kids are hyper, right? They will not listen to you, okay? Want to do too much. But parents do what? Control them, inhibit them. Don't go too far, right? Stay here. So upper motor neurons are like parents, okay? So now, you tell me, if the upper motor neuron lesion or damage occurs here, then what will happen? The lower motor neurons will get freedom, right? No inhibition is coming from upper. So they will work freely, right? And will do what? Squeeze the muscle, right? Contract the muscle forcefully, because that's their function. Okay? So in that case, what will happen? The muscles will remain strongly contracted. Make sense? And that is one type of paralysis called spastic paralysis. Spastic paralysis. Have you heard this? No? In this type of paralysis, the muscles are in strongly contractile position. Okay? Now, you tell me, upper motor neurons are intact. Due to spinal cord injury, the lower motor neurons are destroyed here. Then what will happen? Lower motor neurons are not contracting the muscles anymore. Make sense? So the muscles will remain very loose, flaccid. Make sense? So that is opposite. So that is called flaccid type paralysis, in which muscle will lose the tone. No muscle tone is present. Make sense? So very relaxed, loose, cannot contract, you cannot move. Okay? So make sense? So upper motor neurons and lower motor neurons, if lesion occurs, two opposite type of action on the muscle.
They're only caused by injury, though, to the spinal cord, these type of paralysis.
Most of the cases, injury, spinal cord injury occurs due to mechanical injury. Yeah. In case of brain, most of the cases we see stroke, right? Can cause the lesion of that part or damage to the brain. But in spinal cord, mostly due to an accident or external injuries. Okay. So here you see upper motor neurons in the primary motor cortex and lower motor neurons in the ventral horn of the spinal cord. Okay. The last thing is spinal cord injury can also cause three types of paralysis. One is called paraplegia, another is quadriplegia, and hemiplegia. Name is telling you the condition. Paraplegia is the condition in which the lower part of the body is paralyzed. And if injury or transection occurs between thoracic 1 and lumbar 1 vertebrae. So you know thoracic 1 is somewhere here and lumbar 1 is somewhere here. If anywhere in between thoracic 1, T1 and L1 transection or injury occurs, if injury occurs here, right, the part below it will be paralyzed because upper part is still attached to the brain, right? The part below is dissected from the brain, right? So if injury occurs here, below this will be paralyzed. So in paraplegia, how many limbs are affected? Two, lower two, right? Lower two, upper two are intact because above that. Make sense? Now that is paraplegia. Quadriplegia, if injury occurs in cervical, here, then what will happen? How many limbs will be affected? Four, all four, right? Quadri, four. So, as well as the trunk, right? Whole trunk and whole limbs. So, that is quadriplegia. Hemiplegia, if one side is affected, another side is intact. So, that is hemiplegia. So now spinal cord has two sides, two halves. So if one side is affected, that will cause hemiplegia. Now, quadriplegia is the most dangerous, right, situation because you know respiratory muscles are here in the upper part of the trunk, right? If it occurs below this, person will be able to breathe, right? But if it happens here, then respiratory muscles are affected too, right? So that could be a problem. Could be a problem, but not always because your respiratory centers are in the brain stem. Signal must go to the respiratory muscle. Anybody remember this person? So probably very young kids, but he was a very famous, right? Movie person, celebrity. Christopher Reeve. He fell off from his horse and his head hit the ground. So what happened? The head twisted like this, the body and head. So injury occurred here, right? So that caused quadriplegia. Make sense? He suffered from quadriplegia. Anybody remember sitting in a wheelchair, right? So no movement. We have talked about the reflex, 5 component, receptors, sensory input, integration, motor output, and effective.
If you have the spinal cord injury, 100% of the time you will have paralysis. There's no it's never fixable.
It is fixable. I'll talk about that tonight.
Okay, cool.
Okay. So there is a powerful thing that you have in your brain that is called plasticity, okay? Neuroplasticity. And if you can enhance the plasticity, that can fix some of those problems. And exercise is one way, that physical therapy gradually improves, but the brain tissue, once it is damaged, it will not fully recover. That's the problem, okay? But still brain tissue has some stem cells. So if you can, you know how to stimulate them. That is the problem. We don't know about the brain, right? So that's the problem. Okay, so Levinsky's sign is one way we test the motor function. What is this? This is a reflex test. Like you hit here, knee jerk test is a reflex test, right? You know that. This is another reflex test. Another reflex test is we put the light on the eye, right? To see the pupillary constriction, right? So this is one reflex test. what we do, we scratch the sole of the foot like this, okay? Not with something very sharp. You can use your pen or pencil and the back of the pen or pencil and scratch the sole of the foot, plantar surface. And start from the heel and go like this along the lateral side, and then when you come close to the toes, we'll go like this. So we'll scratch like this, and see if the toes reflex, flexion of the toes occur. So this is normal response. If you scratch, the toes will show flexion. Make sense? Now if you see opposite, when you are scratching, the toes are spreading and fanning, extending and fanning, okay? So that is not normal. So this is normal reflex, this is not normal. Not normal is Babinski's sign positive. Make sense? So if you see this, that is Babinski's sign what? Positive. That means that person does not have plantar reflex. Plantar reflex is this. This is called what? Plantar reflex, right? But this is Babinski's sign, positive. No plantar reflex. So if that happens, that means that person might have motor neuron disease or disorder. Now, if you test this in small, very small, like infants, 1 or 2 years, infants, you will see Babinski's sign is positive, because we know that it takes few years to develop the motor system in the body. You all know that, right? That's why kids cannot walk or run immediately, right? Their motor system develops slowly, right? So their motor system is not fully functional. Functions are not established yet, right? So that's why you see Babinski's sign is positive. Don't take to the hospital. Okay? That I found when I was a medical student many years ago. We used to see few of our friends. They every day they are absent in the class. What happened? Because when teacher, taught Babinski's sign, they thought I have Babinski's sign positive. I should go to the doctor. Like every time they learn something new, right? They think, oh, probably I got that. I got cancer. I got kidney failure or something like that. And they would run to the doctor because they are learning new things and the anxiety and those kind of things make them nervous. And that happens every semester. Some students do that. Okay, so don't think that. Okay. Okay, so let's stop here.